Welcome to another new video. Today we are going to talk about data analytics applied to photovoltaics. Have you ever wondered how data can help you improve the performance of your solar plant? Let's find out how to leverage data to make better operational and strategic decisions. Solar power is not just hardware, it's also data. And that data can make all the difference to the efficiency of your operations. In a PV plant, data comes from a variety of sources, such as IoT sensors, SCADA systems, and meteorological data. This data is the main input for advanced analytics. Operational data. Solar plants collect real-time data on the performance of modules, inverters, batteries, and other critical components. Meteorological data. Solar irradiance, temperature, and wind speed are key variables that influence energy production. Financial data. In addition to operational data, investment and financial optimization decisions depend on the projected operating costs and revenues of the plant. Collecting, managing, and analyzing this data will allow you to identify patterns, optimize your operation, and make evidence-based decisions. There are several sources of data within a photovoltaic plant. Let's take a look at some of the most important ones. SCADA systems. The SCADA Supervisory Control and Data Acquisition System collects and monitors real-time data on the operation of inverters, solar modules, and other equipment. IoT sensors. IoT sensors can capture detailed data on performance and environmental conditions, enabling even more accurate monitoring. Maintenance and historical data. Maintenance histories and historical operation data allow to detect performance patterns, identify recurring failures, and optimize maintenance interventions. The challenge is to combine and analyze all this data efficiently to obtain relevant information for important decisions. There are many tools that facilitate data analysis in photovoltaic plants. Let's take a look at some of the most commonly used ones. Power BI and Tableau. These visualization tools enable the creation of interactive dashboards that facilitate real-time monitoring of plant performance. Python and R. Programming languages such as Python and R, together with libraries such as Pandas, allow advanced analysis of large volumes of data. Big data and cloud computing platforms. Cloud platforms such as AWS and Google Cloud allow for efficient processing of large volumes of data and more complex analysis. These tools not only allow you to better understand your plant's behavior, but also to make informed and proactive decisions. To get the most out of the data, it is important to focus on the key metrics that define the performance and efficiency of a PV plant. Performance ratio. PR. The PR measures the efficiency of the plant by comparing the actual production with the theoretical maximum possible production. Capacity factor. The capacity factor indicates what percentage of the time the plant is operating at maximum capacity. Inverter efficiency. Inverter performance is key, as any loss in this component directly affects plant output. These metrics will allow you to monitor and adjust your plant's performance on an ongoing basis. As we have seen, data is at the heart of PV plant optimization. Collecting, analyzing, and acting on data will help you maximize operational and financial efficiency. If you want to implement these tools in your plant, contact me on LinkedIn. Remember, data is power, and with it, you can transform the future of your solar projects.